Good afternoon, this is Schweitzer, and we're going to look at a second video here on how we're going to go about adding what we call functional groups. So in typical fashion, the way we would just describe this is we're going to give the longest chain, and then what we're going to do is simply tell what is on our longest chain and where. So then we got to tell what is located on the chain and where, and that is really our entire process that we're going to be using. So let's try an example here. Now this is called an alkane. Anything that has a single bond we would just call an alkanes. So all carbon chains marked as called single bonds, call them alkanes. That's an old term, but it is still used quite often. So it's a 6-carbon chain, 1, 2, 3, 4, 5, 6. Now, that's going to tell us what is there. Let's say a methyl group is what we're adding. And a methyl group is just a straight carbon. There's a carbon hanging off of this chain. And the root problem sometimes causes issues is where. Like, how do I know where it is? Well, this number right here is going to tell us our location. Okay? Location, again, this thing says 4-methyl, but typically we count from the shortest side, meaning that we want this number to be as small as possible. And I also mentioned that if you count from one side, like going this way, then everything is counted on that molecule from the same side. You can't start counting, like if we have another methyl group here, you can't say this is on the 3rd carbon and this is on the 2nd carbon. You just got to pick away. And it gets a little bit complicated, but in the end our problems will be quite simple. But we want to start from the short end. So I want to scratch off that 4 and replace it with a 3. So when there's 2 options here, I want to take the smaller of the 2. I'm going to count from the right on this side. So again, 1, 2, 3 is the shortest point, and I drew in the bottom here, draw on top, it just doesn't matter. Okay? Again, this thing can swing around in a circle here, and it could be on top, bottom, sideways. It's a 3-dimensional object. Single bonds can rotate, but doubles and triples cannot. So at this point, we have 1, 2, 3, 4, 5, 6. With a carbon, let's add our hydrogens. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is going to be C7H16. That's my formula for this thing. Alright, here we go. So take a moment, pause the video, try all 3 of these and see if you can get them. If you missed the first one, then pause the video and try the second one after you get the answer. Okay, so it's going to be 1, 2, 3, 4, 5, 6, 7. So this is hexane. And I got to tell them where this is located. So I have a methyl group. So it's going to be 1, 2, count from that side. So it's 2-methyl hexane. This one. Okay. Now this is a little tricky because I bent it a little bit, but that's fine. So this thing's bend and wobble. They're definitely not straight. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. That's my longest continuous chain, octane. And I gotta tell there's a methyl group hanging off of this chain. Count from the short side, 1, 2, 3. It's going to be 3-methyl octane. Let's try the last one. Okay, longest continuous chain, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is simply just going to be non-ane. Okay. And this is going to be C9H20. Okay. Alright, let's flip it over to your next slide. And I'm going to change, we just did 9, so let's change this guy to heptane. Try that guy out. Okay, heptane, it should be in your book, should say heptane. Alright, so draw it out and get the formula. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And hydrogens, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14, 15, 16. So C7H16. 2-methylhexane. So I like to start the back side and go this way. 6 carbons. 1, 2, 3, 4, 5, 6. And on the second carbon, doesn't matter which side you come from, 1, 2, there's a methyl. This is going to be C7H16, just like up there. Alright, 2,2 dimethyl heptane. So again, start this way, go backwards. I got 7 carbons. 2, 3, 4, 5, 6, 7. And I have this location of a methyl, this location of a methyl, and they put a di. It's a little bit redundant, meaning there's 2 of them, because you can see there's 2, but these things get a little complicated, so even though we aren't doing some super complicated ones, but it's just the way it is. Okay, so this is going to be C9H20. Okay. And finally, we have 1-methylpropane. Okay. Alright, so this guy here, again, longest continuous chain is propane. 1, 2, 3. And a 1-methyl. On the first carbon, there's that guy. So, is there a problem with that name? Well, we got it, okay? But again, it's not how people normally do it. This normally would just be called butane. And this would be just C4H10. Okay? Alright, remember, anytime you see a number, it's a location. Well, that's a pretty common type of functional group. Our second common type of functional group is a double bond or a triple bond. So, single bonds have a suffix that is -ane. Double bonds have a suffix that is -ene. And triple bonds have a suffix that is -ine. So these are the 3 suffixes that describe. Now again, typically speaking, we're going to lay out our longest chain and tell what is there and where. Okay, so sometimes you don't have an option of telling where, so we don't bother telling them. Like this guy here is 2 carbons is F. You drop the YL, ethyl, just F, and then it's ene. Now again, there's only 1 bond here, so you could go 1-ethene. That's the location of that double bond, but that's the only option. My hydrogen here and my hydrogen here, the double bond can't go between the hydrogens, so there it is. Okay, and the formula is just going to be at this point. Actually, we have two hydrogens each one. If we want to make them saturated, that's 1, 2, 3, 4. 1, 2, 3, 4. That's C2H4 ethene. Alright, so now you've got a couple of these, and you should be pausing the video and trying these. Okay? So 2-butene, so 1, 2, 3, 4. Now, that's a double bond, and that's the location of the double bond. Doesn't matter where you count from, just be consistent for the molecule. This is 1, this is 2, this is 3, so it's right there. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So on this thing you might note that we lost 2 hydrogens here with that double bond, and we call this thing unsaturated. You might have heard the term unsaturated fat, and that's exactly what they do. Or you might have heard of a thing called hydrogenated. They have partially hydrogenated oils. They take hydrogen and they, with a metal catalyst, shove them in there and remove the double bonds. Okay, 3-pentyne. So 1, 2, 3, 4, 5. 1, 2, this is my third one. Now here's a problem here with this guy, is that we got a little bit of an issue. I put these in here on purpose to see if you can catch them, but 1, 2, 3. But if I move from the right hand side, 1, 2, what's smaller, 2 or 3? And the answer is 2. So I want to do 1, 2, 3, 4, 5. And then I'll add my hydrogens in here in black. So 1, 2, put a double bond right here. And then 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. Ah, it's a triple bond. Okay, so let's redo this here. And let's add our triple bond in here. Okay, so 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. So this guy doesn't get any hydrogens. 1, 2, 3, 4. This guy doesn't get any. 1, 2, 3, 4. 1, 2, 3, 4. Okay. This guy. Let's add our hydrogens here. 1, 2, 3, 4. 1, 2, 3, 4. 4, 4. 1, 2, 3, 4. And then 1, 2, 3, 4. And at that point, how do you get this formula? So it's going to be C6. 1, 2, 3, 4, 5, 6, 7, 8. Alright, H8. What's the name of this thing? Okay, so the longest used chain is going to be hexine. Now, I'm just going to write this on here, but we're going to have a little bit of a change here. We'll see, a little bit of issue. Where are they at? 1, 2, 3, 4. So it's going to be 2, 3, 4, and they do, at this point, that's the locations of the double bonds. They have one small thing they're going to do here. Okay, it's just what they do. Okay, they're going to call it 2, 3, 4 dash hex triene. Just like the last time they had this thing where you had the dimethyl. They do the same thing here where they do triene. And that's located right there. It's something to think about. Okay? Not too common, not too complicated, just a different way of doing it. So triene. I mean three of these, and that's the location. Alright, so we'll stop there and we'll pick up our last video on alcohols. It's coming up next. Alright.